Once again, I am recording this right now as we speak. As I speak, I'm recording. And what we're going to be doing is reviewing solving systems of equations by selecting the best method. And most of the time, it's going to be linear combinations method, also known as elimination method. I want you guys to, in your notebooks, jot down this first example right here. And we could also, you don't have to write down this top statement, but it says sometimes the system is ready to combine and eliminate a variable. Okay. I want to pause it real quick. Please write it down. I paused it for about 45 seconds. Hopefully you copied it down already. Here we go. We first need to be comfortable with the steps on solving linear combinations method or elimination method. Step one is to make sure they're organized. X is on top of X's, Y is on top of Y's, number on top of number. And of course, this system is organized. The X's are on top of the X's, Y's on top of Y's, equal on top of equal, number on top of number. They're both in standard form. That's another way of saying that. Step two, it says multiply one or both equations by a value so that either an X or a Y can cancel out when you combine the lines. You may not have to do this step. So step one, make sure it's organized. It's already done. Step two, if you combine the lines, will something eliminate? Or do you have to actually change one equation or both equations to get something to eliminate? So what you got to ask yourself is this. When I combine 5 and 3, will that cancel out? No, that becomes 8, right? When I combine negative 6y and positive 6y, will that cancel out? Yes, that'll eliminate. So in other words, this system is ready to combine and eliminate the y's. And that's exactly what we're going to do here. I would draw a line right here. Combine the 5 plus 3, that gives you an 8 with an x. And when you combine the negative 6y and the positive 6y, that eliminates. That's why it's called the elimination method. And also when I combine the negative 32 plus 48, that'll give me a positive 16. So I put a 16 right here. Now what about the equal sign? Well, we're going to keep the equal sign right there, stay organized, equal on top of the equals. And what I have here in blue is a simple one-step equation, right? It really says 8x equals 16. Logically, that would say 8 times a number will equal 16. You should already know that that number's 2. But to show the work with algebra, to get rid of multiplication, we use division. That's right. And what you do to one side, you must do to the other to maintain the equality. So what we have is x equaling 2. That's one answer. I need the other. Anytime you have one answer and you need the other, all you got to do is plug it in to the other equation or to any equation. And find out what your other answer is. So which equation would you guys like to plug it into, the top one or the bottom one? Top, bottom, it doesn't really matter, right? Top? All right, on top. So I'm going to take this x value of 2 and I'm going to plug it into the top equation into the x because it's x equals 2. It's not y equals. If it were a y, I'd plug it into y, but it says x equals, so I'm plugging it into x. Now, whoops, that didn't work out the way I wanted to. Here we go. So I'm going to draw an arrow this way to show me plugging in that x value of 2. So I have 5x minus 6y equals negative 32. Again, I said 5x minus 6y equals negative 32. 5x minus 6y equals negative 32. And I think, why the heck did he put parentheses instead of x? Because I know what x is. X is 2. That's why I'm plugging in the 2 right into x. So the 2 goes right in there into those parentheses. And doing the math, 5 times 2 is 10. Bring down the minus 6y, bring down the equal, bring down the minus 32, and that is now a simple two-step equation. So all I have to do now is get y by itself. So I need to get rid of this 10 and this minus 6. Which one do you get rid of first? The 10. Okay, remember, this is the movie star, this is the movie star's buddy. That guy's a loner, the bum at the corner. Get rid of that guy first. So to get rid of the 10, you're going to do the opposite of 10, which is subtracting 10. What you do to one side, you do to the other, subtract 10. And of course, you will have the negative 6y left over, the equal sign coming down, and negative 32 take away 10, that's a negative 42. Now what that really says is negative 6 times y equals negative 42. So you divide by negative 6, divide by negative 6, and of course, y equals a negative divided by a negative is a positive 7. So how do we type in our answer on the actual quiz? You put in as a coordinate 2, 7. 2, 7. Now if you have time left over on your quiz, or your test when you're retaking it, take the x value and the y value and plug them in to here, and you'll be able to see if it does give you a true statement. Plug in the 2 and the 7, see if it does give you a true statement, if you have time. If not, if you feel pretty confident, then you're ready to move on to the next one. But this was an example of step 1 and step 2 already being done for you. They're already lined up, it's already organized. It's already even ready to combine and eliminate, right? So I have another system right here. I'm going to pause it, and I'm going to allow you to try it. It's the same situation. They're already lined up, it's already organized, and it's already ready to combine and eliminate a variable. You don't have to do anything to this. It's ready to go. So I'm going to pause it, and you guys work on it. Go for it. So you got to recognize that both 7s are opposites, right? So it's ready to go. It's ready to combine and cancel. Not the y's, but the x's are ready to eliminate. So what we're going to do here is draw a line like this, and we're going to combine the positive 7x with the negative 7x, and obviously that will eliminate. 7, take away 7, eliminate. So there are no more x's. But when I combine the 2y, and I hope nobody made the mistake of forgetting that there's really a 1 right here in front of the y. I know a lot of students forget that there's a 1 right there. So there's an invisible 1 right there. So what we really got is 2 y's up here plus 1 y down here. What will that give us? 3 y's down there. 3 y's equaling, and of course, up here 10, take away 6. What is that? -6, right? Use a calculator if you're bad with adding and subtracting with the positive and negative signs, or just think of money. You have $10, you owe $16. You can't pay off all $16. You only have 10. You're still going to owe 6, all right? So there's your new one-step equation. 3 times y equals -6. So in order to get rid of the multiplication of 3 in front of the y, you're going to have to divide by 3. And what you do to one side, do to the other. That will leave you y equaling a -2. So you were right, Gabriel. It is -2 on the y. But how do you find out the other answer, the x value, if you already know the y? Well, you plug it back in. Now, which one do you like to plug it into, the top or the bottom? Top one, sure. And it doesn't really matter. You're going to get the same answer, whichever one you pick. But I want to go with the top one. And the top one reads 7x plus 2y equals 10. 7x plus 2y equals 10. Here goes. 7x plus 2y equals 10. Now, what? You might be thinking, why did he put parentheses instead of y? Why did I put parentheses on the y instead of y? Because we know what y is. We know that y is -2, so that's what we're going to plug in. So the -2 is going to go right in there. And now we need to do the math, right? We need to actually multiply. What is 2 times -2? -4. So I really have a -4 right here. I have a 7x in front. I have an equal sign and a 10 on the right side. So that's a two-step equation. Everybody should be good at solving two-step equations. What do I get rid of first, the 7 or the -4? The 4. How do I get rid of a -4? Adding 4, that's right. What I do to one side, I must do to the other to keep the balance of the equation, to keep the equality going. And on the left side, I have a 7x left over. The equal sign comes down, and 10 plus 4 is 14. What does that really say? It says 7 times x equals 14. To get rid of the multiplication of 7 in front of the x, you would divide by 7, divide by 7. That'll give you your answer, x equals 2. Okay, so our answer typed in, open parentheses, 2, comma, -2, close parentheses, right? Ordered pair, has to be in order, x first, y second. Of course, if you had time, plug in those x and y values into both of the original equation of the system, and it should be checking off as a true statement, giving you 10 and giving you -16. All right, so both of those examples that we just went over, those were ready to combine and cancel. Like you just looked at it and you're like, yep, those y's will cancel out, ready to go. Yep, those x's will cancel out, ready to go. Now down here, wait, the y's are not ready to cancel. If I add those, it gives me 7. If I add these, it gives me 4. It doesn't cancel. So this is one of those situations. It says up here, sometimes you have to modify one equation to get something to eliminate. So we need to either cancel out x's or y's. What do you think would be a good idea to cancel out? X's for sure. Now, there's many roads to the same place. Let's talk about why it's better to cancel out x's. Well, you have 2 right here. All you need down here for it to eliminate is what? A negative sign. That's it. So it's easy to change this 2x to a -2x. All we have to do is multiply the whole bottom equation by a -1, right? But let's say you wanted to cancel out y's. Well, then you would have to change this to be the exact opposite of this, or this to be exact opposite of that. Now, you can't, like 2 times what would give you a -5 that'll cancel with a +5. It doesn't work. 2 times what gives you a -5. It doesn't work. So in this case, if you wanted to forcefully cancel out the y's, you would have to change this to become a +10 and this to become a -10, right? But we'll do that later. Right now, let's go with the easier option of getting rid of those x's by simply multiplying the bottom equation by a -1. Okay, so if we multiply everything on the bottom by -1, we will get -1 times 2x, it's a -2x. -1 times +2y, it's a -2y. -1 times +6 is -6. Are you with me? Now that top equation, nothing changes. We're just going to rewrite it. Just going to rewrite it over here on the side. 2x right above it, stay organized, plus 5y right above it, stay organized, equals -3. And now that we've modified the bottom equation by multiplying by -1, now we will be able to combine the lines and eliminate the x's. 5 take away 2 is 3, and we're talking about y's, equals -3 minus 6. You owe $3, you owe $6, you're going to owe $9. Now, what does that blue equation, that one-step blue equation really say? It says 3 times y equals -9. How do I get rid of the multiplication of 3? Divide by 3. Divide by 3. So here's my answer. Y, because it canceled out, equals -3. Okay, y equals -3. I have one answer. I need the other. All I have to do is plug it into any equation I want. Which one would you like, top or bottom? Top one? You know what? Let's plug it into the bottom one this time. It doesn't really matter. Whichever one you pick, it should work out exactly the same. The bottom one, it reads 2x plus 2y equals 6. Again, 2x plus 2y equals 6. I want to repeat that one more time as I write it. 2x plus 2y equals 6. Why did I put parentheses instead of y? Because I already know what y is. Y is -3. So I put parentheses because I want to plug in that -3 right in there. So the -3 is going to go right in there. And here's my new equation. 2x, what's 2 times -3? That's a -6. 2x minus 6 equals 6. Now I have a simple two-step equation right here. I need to solve it. I need to get rid of the 2 and the -6. Which one do I get rid of first? -6 by doing the opposite, +6. And when you do to one side of the equal sign, you must do to the other side of the equal sign. So what we have now is a 2x equaling 12. And for my last step, I would divide by 2, giving me x equals 6. So there's our answer. How are you going to type it in? You're going to type it in as an ordered pair. The ordered pair is 6 first, -3 second. And of course, if you wanted to double check your answer, you could plug in the 6 for x. You could plug in the -3 for y. 2 times 6 is 12. 5 times -3 is -15. 12 minus 15 is -3. Check. Over here, 6 for x, -3 for y. 2 times 6 is 12. 2 times -3 is -6. 12 plus -6 really is 6. Check. We've double checked it. We know for a fact that this is the correct answer. Now, both of these examples, this one example, I'm sorry, the previous two, they were ready to combine and cancel. This one, we had to modify one equation. How about this one? We're also going to have to modify one equation. All right? You need to decide, there's many roads to the same place. You need to decide whether you want to cancel out x's or y's. And I want to just step one step towards each of the directions so you could decide which one's better for you. Let's say you wanted to cancel out x's. Yeah? This is 7x up here. What would you need this to be down here? If this is a 7x and you wanted it to cancel, what would this have to be? A -7, right? How could you change this regular 1x to a -7x? You'd have to multiply by -7. All right, so that's one path, one option. Now, what if, just for a second, we think, well, how about the y's? I have positive 15y up here and a -3 down here. If this is a positive 15y up here, which it is, what do I need this to become for it to eliminate with positive 15? A -15, right? Now, what would I have to do to get rid of, or to make this a -15? Multiply by 5, right? So the question is, do you want to multiply by -7 to get rid of the x's, or multiply by 5 to get rid of the y's? Probably 5s, right? It's a little easier to multiply by 5s than by 7s. So that's why I went through that thought process. Hopefully you guys understood it. We are going to multiply the bottom equation by 5 to cancel out the y's. And I hope everybody's keeping up with me as we go. So the top equation, we're just going to rewrite it right here. 7x plus 15y equals 32. Bottom equation, we're going to distribute 5 times x, 5x. 5 times negative 3, negative 15 with the y. 5 times 20, that is 100. And now that the y's are ready to eliminate, you could have eliminated x's if you wanted to, but now that the y's are ready to eliminate, I put a line right here. I actually eliminate the 15y with the negative 15y, and I combine the lines. 7 plus 5 is 12. The equal sign comes down, so we have 12, nothing else, equals, 12 equals, well, I'm sorry, I forgot the x. 12x equals 132. I apologize. 7x plus 5x is 12x. I forgot the x. 12x equals 132. This is a one-step equation. That one-step equation reads 12 times x equals 132. Get rid of the multiplication of 12 by dividing by 12. What you do to one side, do to the other, and you will have x equaling 11. So we have one answer. We need the other. How do we find the other answer? Plug in the 11 into x into any equation you want. Which one looks easier to work with? The original bottom equation or the top one? The bottom one, right? I'd rather work with x than 7x. I'd rather work with a minus 3 than a plus 15y. I'd rather work with 20 than 32. So I'm going to use the bottom equation, and it doesn't matter which one you use, but I'm choosing the bottom. X, well, actually, let me read it first. X minus 3y equals 20. X minus 3y equals 20. X is 11, so I'm going to put parentheses instead of x. X minus 3y equals 20, and I'm going to plug in that 11 for x right in the parentheses. Now, there is nothing to multiply by. There is no multiplication of 2. There's no minus sign out here in the front, so you don't even need the parentheses. It's going to be a regular equation that reads 11 take away 3y equals 20. Again, 11 take away 3y equals 20. Let's get y by itself. What do I get rid of first, the 11 or the minus 3? 11. How do I get rid of 11? Minus 11. That's right. What I do to one side, I do to the other. 20 take away 11 is 9. Bring down the equal sign. Bring down the minus 3y. A lot of students forget about the minus. They just bring down the 3y, and then it becomes wrong. It's a minus 3y. So put down minus 3y. And in reality, what that says is negative 3 times y equals 9. So I need to divide by negative 3, divide by negative 3. And that'll give us what as a final answer? Y equals negative 3. Okay, so we're going to type in our answer with parentheses. The x value always has to come first. The y value comes second. There's your answer, 11 comma negative 3. And this is another example of only having to modify one equation, right? We didn't mess with the top one. We just rewrote it. Same exact thing. We only modified the bottom equation. Now, there will be the most challenging times where we have to modify both equations to get a variable to eliminate. Okay, sometimes you have to modify both equations to get a variable to eliminate. So again, we're going to look at both paths to the same place. If I wanted to cancel out x's, well, I would need this to be a positive 4 to cancel out with a negative 4, but that doesn't work. I would need this to be a negative 7 to cancel out with a positive 7, and I can't do that. So the way to, you're going to have to modify both. If you want to cancel out x's, I recommend multiplying this number by that number. Or if you wanted to cancel out y's, I recommend multiplying the top equation by the bottom number 7 and the bottom equation by the top number 6, right? So in other words, I would need this to be a 12 to eliminate with the negative 12. Or I would need this to be a negative 42 to eliminate with the positive 42. So obviously 12 is smaller, 3 and 4 are smaller than 6 and 7. So I would choose to eliminate x's, right? You don't have to. You could choose to eliminate y's, but you're going to deal with bigger numbers, which is more likely to make a mistake with bigger numbers. So I'm going to change the 3x to a 12x, and I'm going to change the minus 4x to a minus 12x. Again, 3 and 4 are the numbers I will be using. The top equation, I'm going to multiply by 4. That way it'll give me a positive 12. The bottom equation, I'm going to multiply by what? By 3. That way it'll give me a negative 12. Again, because the numbers are 3 and 4, I'm going to be using 3 and 4, but I want the opposite value. So positive 12 and negative 12 is what I want, and that's what I get by modifying those equations the way I just did right there. So the top equation, multiplying everything by 4. 4 times 3 is that 12x that I wanted. 4 times negative 6 is negative 24. You have a y on it. 4 times 9 on the other side of the equal sign is 36. Use a calculator if you don't know your multiplication tables. Bottom equation, 3 times negative 4 is negative 12x. 3 times positive 7 is positive 21y. And 3 times 16, negative 16, use a calculator, that'll be a negative 48. And now, since we modified it to get the x's to cancel, it's ready to go. You got a positive 12x that will eliminate with the negative 12x when you combine those lines. The negative 24 and the positive 21y, it's like if you owe $24, you have $21, you can't pay off all $24, but you can pay off the 21 that you have, you're still going to owe 3 of those dollars, in this case 3 of those y's. Use a calculator if that doesn't make sense. And over here, 36 take away 48, you have $36, you owe $48, you're still going to owe $12. Are you with me? So now we have a one-step equation here. This says negative 3 times y equals negative 12. So we're going to divide by negative 3, divide by negative 3. That will give us our first answer, y equals positive 4. Why positive? Because a negative divided by a negative is a positive. So we have one answer. We need another answer. We're going to either plug it into the top or to the bottom. What do you guys say, top or bottom? Top. And doesn't even matter. I'm going to go with top just because the numbers look a little bit nicer. 3 is less than 4, 6 better than 7, 9 is better than 16. I'm going to go with the top one. So the top one reads 3x minus 6y equals 9. Again, 3x minus 6y equals 9. Whoa, why didn't I put the y right there? Why didn't I put the y? Because I know what y is. Y is 4, so I'm going to put a 4 right in there. Okay? Let me show some lines and some arrows. The 4 goes right in here. Do the math. Negative 6 times 4 is negative 24. Bring down the equal sign, the 9. Bring down the 3x in front. There's your new two-step equation. 3x minus 24 equals 9. Yeah, we get rid of the 24 first before the 3. So we're going to go plus 24. Plus 24. The equal sign, we're just going to bring it right down. 9 plus 24 is 33. And the 3x on the left side, that's going to come down. So we have 3x on this side. All we have to do now is get rid of that multiplication of 3 by dividing by 3, giving you x equals 11. So final answer here in coordinate format, x value first, y value second, 11, 4. Of course, if you have time, you could always plug in your x and y values and double check your answers and see if it actually works for both equations in the system. And guys, honestly, this is as hard as it gets. It doesn't get any harder than this. The whole entire test, the whole entire Unit 6, there's nothing harder than having a system. Nothing harder than having a system. Why did that happen with the 4? Nothing harder than having a system that has you to modify both of them, right? Sometimes they're ready to combine and eliminate. Sometimes you only have to change one equation. But this is as hard as it gets, where you have to change both top and bottom equations by something, in this case by a 4 and a 3, right? So you could use elimination method on any system. Even if they tell you use a different method, you could still use elimination method. This worksheet right here was from a couple of weeks ago, and it went through showing you the different methods. Like right here, if I wanted to, even though it says, or even though they're both in slope-intercept form, I could modify them and line them up. Like for example, if I did not want fractions, I could multiply by 3, multiply by 3, multiply by 3. That would give me a new equation that reads 3y equals 2x plus 6. And then I could move the 2x over here, and my new top equation would be a negative 2x plus 3y equaling 6. And then I could do the same for the bottom by multiplying by 3 to get rid of the fraction, everything by 3. That times 3, that times 3, that times 3. And that would give us a 3y minus 5x. 3y equals minus 5x and then plus 6. And then I would get rid of the minus 5x by adding 5x, and you'd have 5x plus 3y equals 6. 5x plus 3y equals 6. So here's your system that's organized. But see, that would technically be a waste of time. But I'm just saying, I'm letting you know, you could use elimination method on any system. But obviously, if it looks like it's ready to graph with y equals mx plus b, especially if you see that the b's are the same, you technically already know your answer if you think of the graph. So what is the answer? Well, the top equation, if I were to graph it in blue, yeah, crosses at 2 and it goes up 2 over 1, 2, 3, and there's your line. And the other one, if I were to graph it in red, crosses at 2 also right there. And in this case, it goes down 5 over 3, down 1, 2, 3, 4, 5 over 1, 2, 3. So it would be over here. Connect those dots. And we know that the point of intersection is a solution. So that solution is 0, 2. So obviously graphing is way faster than doing this mess over here and then barely having your system. But you could, if you wanted to, then from there think like, okay, I want to cancel out either x's or y's. Oh, I want to cancel out y's. I want to multiply the bottom one by a negative 1. So that bottom equation is going to be a negative 5x minus 3y equals negative 6. The top one's going to stay the same, negative 2x plus 3y equals positive 6. And you will see that when you combine them, you get a negative 7x. These guys eliminate, and that eliminates, giving you a negative 7x equaling 0. Then you would divide by negative 7, divide by negative 7, and you'd get x equals 0. And that's one answer. And if you wanted the other, you'd have to plug in 0 back in to solve for the other. But we already know that graphing has its benefits if it's set up to graph y equals mx plus b. You already know your answer is going to be 0, 2. All right? Over here, we just found out that x was 0. If you were to plug it back in here, you'd get the 2 for the y value. But it was a heck of a lot faster graphing. So look how fast this one is. This one doesn't have the same b values, but it does have the same what? The same, what are these called in terms of y equals mx plus b? The same m values. So they're going the same slope values. They're going in the same direction, same steepness. If they have the same slope, that means that they will never cross, which means what? That this guy, no solution. Yes, they are parallel. That means they'll never cross. So obviously this is way better than multiplying to get rid of fractions, then organizing it with your x and your y on the left side, and then thinking about eliminating x's or y's. You're going to get no solution here on this one. You could also use substitution, but substitution, I would, if you want, just skip out on that, right? If you were struggling with the Unit 6 test, don't bother doing substitution. Substitution is pretty easy, but it's just as easy, especially if one equation is already organized, x plus y equals a number, your x's, your y's, and a number. This one is not organized. So I want my x plus my y equaling a number. Over here, I have a y equaling an x with a number. The x needs to be over here. So you could just change that bottom equation by adding x, and that top equation is going to stay 3x plus y equals 12. That bottom equation, you're going to rewrite it x plus y equals negative 2. Now, here's your system that's now organized. What would you like to cancel, x's or y's? Y's, okay. What would I have to do to eliminate the y's? I'd have to multiply either equation by negative 1. So I'm going to go with the bottom equation, multiply it by negative 1. That way this will become a negative y that'll cancel with the positive y. So on the top, I'm going to leave it exactly the way it is, 3x plus y equaling 12. The bottom equation we're going to modify. It's going to become a negative 1x, or just negative x, minus 1y, or just negative y, equals a positive 2. Okay? And now we are able to combine and eliminate. 3 take away 1 is 2x. Y minus y cancels out, it eliminates. And 12 and 2 is 14. So we put a 14 right here. Now this is a one-step equation. 2 times x equals 14. Divide by 2, divide by 2. There's your first answer. X equals 7. Okay? So you want your other answer, all you got to do is plug it back in. So plug in 7 into any equation you want. Which one do you want? The blue bottom one or the black top one? Or we could even go back to the original. That would be pretty simple. You could even do that in your head. Plug in a 7 right here. That'll say minus 7 minus 2. What's a minus 7 minus 2? Minus 9. So you already know your answer, y equals minus 9. But if you wanted to plug it into any other equation, you could do that as well. Like let's say you wanted to plug it into the top one. Top one reads 3x plus y equals 12. Why did I not put the x? Why did I put parentheses? Because I already know what x is. X is 7. So we're going to take that 7, plug it in right there. 3 times 7 is 21, plus y equals 12. So subtract 21, and you will get y equals What is that? Negative 9? So those are your answers. 7, comma, negative 9. Now if you're thinking, wait a minute, that doesn't sound good. 7 and negative 9. You could always double check it by plugging in the x being 7. So minus 7 minus 2. Is that a minus 9 on the y? Yes, it is. So the bottom one works. The top one, plug in a 7 right there. 3 times 7 is 21. Put a minus 9 right there. 21 minus 9, that really is 12. So it does work. Absolutely positive that this is the correct answer for that system. So again, this was originally a question that asked you to use substitution, but you don't have to use substitution if you're good at elimination method, right? All you got to do is organize your system first, arrange it. X is on top of x's, y is on top of y's, number on top of number, and then you could think about canceling out either x's or y's. Totally up to you, okay? What else? Now, of course, we're going to have some that have no solution or infinitely many solutions. Right here, if you wanted to cancel out what would you guys like to cancel out, x's or y's? I'd go with y's because they seem a little bit smaller than the x's. I'd have to multiply this, I'd have to multiply this top y by 6, so it'll cancel with the negative 6. Now, when I do put a 6 right there, my new top equation will be 6 times negative 2, that's negative 12 with an x, 6 times 1y, that's a positive 6 with the y, 6 times 3, that's equaling 18. And on the bottom, I just rewrite it. 12x minus 6y equals negative 18. Okay. Now we're ready to combine and eliminate those y's that I wanted to eliminate. So the y's do eliminate, but the x's also eliminate, and the 18's also eliminate. So I got 0 equals 0. It's no solution when it's impossible. When you have like 0 equals 5 or 0 equals negative 13. But when it's 0 equals 0, that's always true. And it's always true because technically these lines, these equations are the same equation. They don't look alike, but when you graph them, you'd see that they'd be exactly the same. So you would say IMS, infinitely many solutions. Again, if you end up with the x's and y's canceling out, and it's exactly, it's always true, 0 equals 0, you say infinitely many solutions. If x's and y's cancel out and you end up with something impossible, like 0 equals, like let's say this was a 10, take away 18, 0 equals negative 8, then you would say no solution. But if it's always true, infinitely many solutions. If it's impossible, no solution. And that's a wrap, guys. I mean, I've been going over a lot of examples here. Solving systems, you could use linear combinations on every single system that you solve. We're going to retake this thing on Wednesday, so please study.